All right, so this is exercise 6B, question number 20. I just thought I'd do this on the board so you can have a look. It says find the values of lambda that make y equals e to the power of lambda x. Okay, now the light's right on it, so we'll see what we can do. But anyway, you'll have your question in front of you by looking at exercise 6B, question 20. So we want to find the values of lambda that gives a solution for this particular question here, which says the second derivative of y plus 3 times the first derivative of y minus 10y equals 0. So we know that y is equal to this. So y is equal to e to the power of lambda x. So the first derivative, this is just a constant. We bring the constant to the front, e to the power of lambda x. And the second derivative, we multiply again, so that gives me lambda squared, e to the power of lambda x. All right, so then I have all those values. All I now need to do is substitute them into this equation here. This is part A of the question. I'm only going to do one part because part B is exactly the same, except that you have to use the quadratic formula. Okay, so now if we look at this, I now substitute second derivative, lambda squared e to the power of lambda x plus 3 times the derivative of y, which is lambda e to the power of lambda x, all right, and minus 10y, which is just e to the power of lambda x equals 0. Take out the highest common factor, and I'm left with lambda squared plus 3 lambda minus 10 equals 0. Okay, and all I need to do now is solve. Well, we know that e to the power of lambda x, because it's an exponential value, cannot equal to 0, so we write no solution. And then I have this quadratic, which instead of lambda you could use x, but it's already quite straightforward anyway. So if I factorize this, I end up with lambda plus 5. Let me do this again. Plus 5 times lambda minus 2 is equal to 0, because 5 times negative 2 gives me that negative 10, and plus 5 minus 2 gives me that positive 3. So therefore the solutions for lambda are 5 or, that's negative 5 or positive 2. And there's question 20, right? So that's not too difficult. And for part B, all you had to do, well, it's the same idea, but once you get to this point here, you cannot, you have to use the quadratic formula to solve for lambda. All right, that's it for that question.